Welcome to chapter 5. We have a file called sarojinipoem.txt inside the chapter 5 folder. I'm going to go inside it. The very first question asks us to print the contents of this file onto the terminal. Here's one way to get this done. You have to open the file, provide the path to the file name. Since I'm going to execute this file o1_a from inside chapter 5, and both these files, that is this Python file and the text file, are in the same directory, it is sufficient to provide just the file name. Open is going to return a handle to the file. This file is going to contain a method called as readlines, which is going to return a list of strings, each of which does not strip the new line character at the end. So when you print iterating through the list, you want to set end to be an empty string. Here it is in action. There we go. That's the first question for you. The second part of the first question asks us to print each line in reversed order. I'd like to introduce you to the with construct here. If you look at the first part, 1a, we opened the file, read the contents, and then closed the file after reading the contents. When you use with, it implicitly closes the file handle when the code block inside it comes to an end. So you don't have to explicitly issue a file.close. So similarly, we just go ahead and read lines, and after that, since text is now a list of strings, you use reversed, and now we print from the end all the way to the start. So here's the output. Let us now look at the third subproblem. We are asked to copy the contents of the file sarojinipoem.txt into an output file. We can call it output.txt. Couple of things to notice here. With can take any number of parameters which are context. So we have an in file that points to the open call of sarojinipoem.txt, and we have an out file which is created with the w flag, which will create a new file if it doesn't exist and truncate if it already existed. And after that, this is straightforward, right? For every line in this in file, we just write it to the out file. So upon running this, we'll notice that this program has run to completion. One way to confirm that the contents are actually the same is to go ahead and execute a command called diff. Diff will produce a non-empty output if the file contents are different. In this case, they are the same. So we can be confident that both the files are the same. Moving on to the fourth problem in question 1. We're asked to append the content of sarojinipoem.txt onto another file, output.txt. We use the a flag instead of the w flag here. This shows that if the file doesn't exist, it will be created. If the file already exists, content will be added starting from end of the file. So let's run this for the first time. So here we go. This is output.txt for the very first time. Let's run this program again, and you'll notice that content is added again starting from end of file. For 1e, we are asked to print each line in the file sarojinipoem.txt along with an offset indicator. That is, we basically want to print the line number. Here's how the output is going to look. The first one was a blank line, so we'll just see O1 and then a blank line here. The same way we'll see the rest of the lines. If you want to make your output even more pretty, you can add a print statement here. Here we go. That's about it as far as the first problem is concerned. Let's now move on to the second question in chapter 5. Let's start with the output so that we get a better context of what the program is about. So upon running the program, the user is asked to enter a file name. So here's a file name. Since we are in the current directory where both the Python file and the text file are there, it is sufficient to enter just the name of the file. The program now has to count the number of lines in the file, the number of empty lines, the average number of characters per line, and the average number of characters per non-empty line. These are the statistics that we are supposed to print to the user. With this context in mind, let's look at the program. As one might expect, we open the file, read every line, and for every line we increment num lines by 1. One thing here is, when you read a line, the end of line character in the new line character is not stripped. So here I continue to I count the new line character as a character as well. If you don't want to do that, then use rstrip. If the last character is a new line character, rstrip will get rid of it. For counting an empty line, I consider just a new line as an empty line. So this is how you calculate the statistics. Rest of the program is just to make the output look pleasant. For instance, all these numbers will be aligned perfectly to the right, and then you'll have these titles. You can go through this yourself. The core logic lies in these few lines. That's about it. Let's look at the third question. We're asked to create a file called security.txt, and inside that we're supposed to store usernames and passwords. The username is supposed to be unique, and a password is considered valid if it is more than 7 characters, and if one of $@ or one of these 3 characters are present. So let's run this program. So I'll have a dummy user here, and for the password, here we go. We're asked to enter the password again because it did not contain any of those special characters. Let's re-enter the password. So there we go. Now if you look at the file, it contains user1 and then the password. Both are tab separated. So let's go through the code with this in mind. We see if the file exists. If it does not, then touch will create an empty file, a blank file. The size will be 0. So the next thing is username new. So just to give you a demo of that, if we run this and we enter the same username, it'll say that the program will say that user ID already exists, and it will prompt you to enter a new username. So that's what this function is supposed to do. It reads every line, splits it by tab, and checks if the first one is the username. We already have gone through this password check. It should be at least 8 characters in length and should contain one of these special characters. Then here's the chunk snippet to get the username. You get the username, make sure that no tab is there in the username. And other than that, if the username is new, then go ahead and make note of it. Make a similar attempt to get the password. Remember to open the security file in append mode because you want to store more than one username in the file. Store the username and password, and then we're done. So here is another user getting added. Here we go. The fourth question is pretty short. Here's a file called mine.txt with these 3 lines. I am line 1, then a new line, and then I am line 3. We're asked to predict the output of this particular snippet. The reason I'm taking interest in showing this is because it's not as trivial as it looks. So let's break this down. We open the file, returns a file handle, and then we use read lines to read all the lines in the file as a list, and then we invoke print. So this does not print the entire content of the file, but rather prints a list. So that's what you should take note of. Here you go. there is another way to print the lines. So you use the string dot join method. Here you go. Let's now turn our attention to the fifth question. We're asked to enter a file path and print the content of the file in uppercase. So this is straightforward, right? We get the input using the input built-in, open the file, read every line in file, and since line is already terminated by a new line character, .to upper is sufficient, and make sure to set the empty string as end for the print function. There you go, that's the demo. For the sixth question, we're asked to read the file sarojinipoem.txt and create a new output file wherein we swap the case and write the output. One tip in Python, so you can use a backslash to extend your current line to the next line in your text. Without this, the program would crash. If you add this, it's as good as writing this. So let's execute this. Here you go. The letters are swapped in case. Questions 7 and 8 ask us to create a phone book to store the name and the phone number. This is very similar to the security question that we saw a few moments back, except that there is no need to even check for a duplicate entry. So here's what we do. If the file phonebook.det does not exist, then create a new file, write the name and phone number. After that, get the input from user, open the file in append mode, and keep writing to it. That's it. So here's a new entry. Let's look at the phone book now. This is what it has. Let's add another record. Here we go. That's it as far as the 7th and 8th questions are concerned. As an extension, do the same work you did for security. Make sure that the name and phone number pair are unique, because one person can have multiple phone numbers and multiple people can still share the same phone number. Make sure that there are no duplicate records. So name and phone together should be unique. Try that as an exercise. Welcome to question 9. Here's what we're supposed to do. Open the phonebook.det file that we created in questions 7 and 8. Read every record. See if we have a record for Arvind. If so, ask for a new phone number and then save it. As in, overwrite Arvind's phone number with this new phone number. If the file doesn't exist, or if Arvind's record is not found, then inform the user. Based on our previous run of the 7th and 8th programs, here's the content of phonebook.det. So when we run our program, we'll see that the output is printed as record for Arvind, not found. Now let's go ahead and create the record for Arvind. Here's a name. Here's a phone number. To confirm, we see here that Arvind is stored. At this point, if we run the 9th program, we'll be asked to enter a new phone number because this particular if check will pass. We'll finally store the new phone number if user enters 1, save it and get out of the program. That's it. So let's see this in action. So the program informs us that Arvind's phone number is this. Let's go ahead and provide another value. Here we see that Arvind's phone number has changed now. Let's now go through the program to understand the details of how we overwrote a portion of the file. Open the file in read plus mode. This allows you to do both read and write. Read every line. If the read line returns an empty string, then break out and print the error message if Arvind was not found. If the record was found, get the new number, and here's where the interesting thing happens. So let's look at the phone book again. By the time this line is read and the record is located, the file pointer points to the last beyond the last character. So we want to get that location, and when you subtract the length of the phone number, which is 10 characters, you go back all the way here just before the first 3, and then you do the write operation. So it just overwrites this particular location. That's about it. The two important things to notice here are the seek call and the tell call. Seek is used to move the file pointer to a particular location. Seek set says that you want to move with respect to the starting location of the file. And you also have the tell method, which returns the position of the last location that was read. That's about it as far as the 9th program is concerned. There is one more variation that I'd like to share with you, which is going to make this phone book a lot more interesting to work on. If we don't make the simplifying assumption that all phone numbers are 10 digits long, here are fun things that we can run into. Say I enter an 8-digit phone number, it's saved, but let's look at the file. We still have 10 digits here. It's because the file does not get truncated. There's another interesting scenario which will happen if Arvind is not located as the last record, but is located somewhere in between. We'll see that next. Alright, so I've moved Arvind's record to the middle of the file and changed his phone number manually. Let's now see what happens if we run the program again. Here's the 8-digit phone number. As you might expect, interesting things start to happen. Now let's just say, because it's 10 characters, right? We're supposed to have just 8. There's one more thing that can break this phone book. Let's see that in action. Here's another place where the simple program can break. Let's assume this to be our phone book. We have name 1, Arvind, and name 2. All the phone numbers are 10 characters in length. Now let's run the program again. And let's assume now that Arvind has moved. So we have here with his new country code and then his phone number. Let's see what happened. Because we seek and write, we overwrite the other records, and this is bad as far as the phone book is concerned. There's one more place where the whole thing can fall apart. So here again we have a record with Arvind with his new phone number. I manually edited the file to make this change. So let's run the program. Let his phone number be a lot shorter. Now if we take a look at the file again, you see that he now has an invalid phone number. The problem comes when we blindly seek and write without taking into consideration what was already there in the file. Here's how to fix these problems. This part you already know, opening the file and checking to find the record for Arvind. We'll now focus on this particular piece of code. So what we do now is, before writing a new record, we know that our pointer is currently right at this location. The next time we issue a read line, we're going to get name 2 and this phone number. So what we need to do before writing is copy the rest of the file content from the place where we encountered the record for Arvind. So once this record is copied, if Arvind was not the last record, then we must add a new line to his phone number as well. After that, write his new phone number and the remaining content. To make sure that if Arvind's phone number became shorter than what it was originally, we go ahead and truncate the file so that the rest of the excess digits will be removed. We still have room for one small optimization. That is, if the number of digits in Arvind's phone number didn't change between what we enter and what is there in the phone book, then we don't have to go ahead and copy the rest of the file and then write it. So this code should look familiar. If the length of his new number is the same as the length of his old number, which was stripped, so even if it was at the end of the phone book, it doesn't matter. The new line character will be removed. So then you go ahead and write his phone number right where it. This brings us to the end of the 9th question, the demo of this program. So here's the phone book side by side. So let's mention the new number as the same 10 digits. You see that it gets written properly. Now the next scenario is to have a shorter phone number. Here's a correct phone number. The rest of the records are not corrupted. At the same time, Arvind's phone number remains correct. Let's make the phone number big again. You see that the record is persisted correctly. You can try it out by keeping even Arvind as your last record, and the behavior is going to be the same. So if you make this as a new phone number, it works. If you make this as a phone number, works as well. We can go back to making the phone number bigger and it will work as expected. That's about it as far as the demo for the variation is concerned. Welcome to the 10th question in chapter 5. Here's what we're asked to do. Create a binary file named items.dat and then store a dictionary for every item which has item number, name, price and category fields. They're asking us to store a few records of this type. So here it is. You open a file in write binary mode. The B stands for binary. We're storing 10 records. Using pickle.dump, we'll save the record to the file, and this is a helper utility that is provided for you, as in we've written it separately. It's not asked as part of the question. Couple of things that I'd like to point out here. When you open a file in binary mode, it has to be read binary. Here is how to get the number of bytes in a file. You seek to the end, use the tell method to get the position. That will give you the position of end of file. Then you seek back to the start of file and then start reading. If you have reached the end of file, then break. If not, continue to parse the record and display it to the user. Here's the output. Some of you might use an exception based approach wherein you won't use this seek to the end to get the offset and so on. Instead, you will just read the record, and if an exception is raised, then you will break out of the while loop as well. In my opinion, this is a lot cleaner because we know that this is a scenario that can be prevented and there is no need to use exceptions. So depending upon what you've been advised in your school, pick your option. Moving on to the 11th question. Now they've asked us to add a few more records to the same file. To show you how many records we've written, we have till item number 9. So let's go ahead and run 11, and after writing we now have all the way through record 19. So here's what we have from 0 through 19. To open a file in append mode, you use the A flag, and since this is the binary file, you use B suffix as well, and the rest of it is self-explanatory because instead of just writing, you're just opening the file in append mode and you're still continuing to add records. The 12th question here asks us to do the following: get an item number and also a new price. Set the new price for the item that is found in the binary file that we have been playing with so far, items.dat. So we get the item number as an int, get the price as float. We've opened the file in read plus and binary mode. R plus means that you can do both reads and writes. We go to the beginning of the file, get the end of file marker, and then we search to see if the item number matches the item number the user has entered. If it is found, you update the price seek to the particular position from where the record read began, because once you do a load, the read pointer would have moved past the end of the record. You want to go to the start of the record, and then you want to write the price, as in you want to write the complete record. So go ahead, dump it, and then break out of the while loop, and that's it, you're done. If the item was not found, just inform the user. Here's the demo. Item number is say 0. Say the new price is 123. So here we go. This is the new price, and that's it, we're done. Here's an extension for you. Instead of getting the price from the user, get the name from the user. There is a reason why we didn't have to take so many precautionary steps like when updating the phone book. This is because price is a float and the size of a float is fixed in Python. So we can comfortably overwrite the dictionary in place. Whereas if you were to get the name, then you'll run into problems similar to the phone book question. You can, instead of category 0, you can say I want to enter category, say, a big name. In that case, this program is going to crash. Try to fix it yourself. For those of you who have been watching these videos from the start, this question is very simple. They're asking us to collect the item number to skip and then write the rest of the items to a new file called itemsnew.dat. So here's the demo. If you want to skip, say, item number 0, then now you have all the way from item number 1 all the way through 19. Here's how to get this done. First, we go ahead and get the input from user, convert it to an int, and then open the file in read binary mode. Keep searching. As long as we don't need to skip, we continue to write the item in the out file. If we need to skip, we won't do the pickle.dump command, and that's about it. Welcome to the 14th question. So here we're asked to create a CSV file and then write a bunch of records. In your textbook, you'd have been taught about CSV Reader and CSV Writer. I'm going to take a slightly different approach. We're going to end up using Dict Reader because it's a lot easier to understand. In your CSV Reader and CSV Writer approach, you have to know the position of the fields in which you have to write. Here, since it's a dictionary, write will always happen in the order in which the field names are provided. So I'm showing you a demo for 2 records, but in the textbook they've asked you for 10. All you have to do is change this 2 to 10. Item number is 1, item name is N1, price is . So here you go. Now that we've written all the records, I'm calling display records. Here is how you use the Dict Reader. You provide the Dict Reader the file to read, and then each row is written as a dictionary. This is a lot more convenient, and secondly, it's robust, because if someone was to give you a CSV file, all you need to know is just the field names. You don't have to know the exact field positions because they can keep varying from vendor to vendor, and it makes the parsing of CSV files a bit more robust. Ask your school, see if you can use Dict Reader and Dict Writer instead of csv.reader and writer. That's about it as far as the 14th question is concerned. One tiny detail, since item.csv is a non-binary file, you can still use commands like less to view the records. See here, the order in which the field names are provided is the order in which write is happening. Here's the 15th question. Here they ask us to use a pipe as a delimiter instead of comma, which is the default CSV delimiter. We go ahead and specify delimiter when writing as well as when reading. As always, when you write header, it writes the field names on top of the file. You issue this as the first statement, which is why it writes it at the top of the file. And here I've shown it for range 2. You can change it to range of 10 for 10 records. For the sake of demo, I've reduced it to 2, less typing. When you look at the file, here we go. We have everything separated by a pipe. That's about it as far as the 15th question is concerned. 16th question asks us to implement the search functionality for a CSV file. So we're going to pick items new.csv. The records are shown here. If the record is found, then we print that the record is found and we print the details. If not, we inform that the record was not found. The search is based on the item number field. So let's see how this works out. Item number 1, yes, we found that. Item number 4, not found. That's about it as far as the 16th question is concerned. Welcome to the 17th question. Here's what we are asked to do. Open the file items.csv in read-only mode. Find those records where the price is more than 250 and then write those records to a new file called highitems.csv. Say. So I've manually edited the underlying CSV file. So these are the records. We should pick just records N2 and N4 because their price is more than 250, and we should write them into a new file called highitems.csv. Open these two files, one in read mode and the other one in write mode. Create instances of Dict Reader and Dict Writer. You know to do that by now. Write header into the output file because we want this field name information on top of the file, and then iterate to the records and write to the output file if necessary. Let's run this in action. Okay. So here we go. Only records N2 and N4 got written. This brings us to the end of the 5th chapter.